Alright, you're welcome again. Today, let's talk about limits. Let's take a look at this question. Evaluate number 1. Limit as x approaches 0, 2ax sine x all over 3x squared. And then number 2. Limit as x approaches 0, sine squared x all over 4 all over x squared. Okay, good. Let's go. Let's take them one after the other. Number 1, we have limit as x approaches 0, 2ax sine x all over 3x squared. Now, in this limit, we can split this into 2. It's still the same thing as saying limit as x approaches 0, x sine x all over x squared times 2a all over 3. Hello. You know, when you multiply the numerator multiplied by numerator, this place we have x sine x multiplied by 2a. It's still going to give us 2ax sine x. And then the denominator multiplied by the denominator, here we have x squared multiplied by 3. It's still going to give us 3x squared. Alright, good. Now, we see clearly that this 2a all over 3 is a constant. Let's pass it at the back of limit, okay? Now, let's take it behind the limit. That means we are going to have 2a all over 3 multiplied by limit as x approaches 0, x sine x all over x squared. Hello? X sine x all over x squared. Now here, this x at the back of sine, we cancel 1x in the denominator. That means we are going to be left with sine x all over x. So here we have 2a all over 3, limit as x approaches 0, sine x all over x. And then anywhere we have limit as x approaches 0, sine x all over x is always 1. So here we have limit as x approaches 0, sine x all over x, which is equal to 1. And then we have 2a all over 3 multiplied by 1, which is equal to 2a all over 3. So here we say that limit as x approaches 0, 2ax sine x all over 3x squared is equal to 2a all over 3. All right. Yes. Now let's take a look at number 2. Number 2 say limit as x approaches 0, sine squared x all over 4 all over x squared. You get it? Now, in this place we have sine squared. Now this sine squared is still the same as opening the sine in 2 places. That means we are going to have limit as x approaches 0, sine x all over 4 times sine x all over 4. So when you multiply this together, it's going to give you sine squared x all over 4. And then in our denominator, where we have x squared, it's still the same thing as saying x times x. All right, good. Now let's split this into 2 entirely. That means we're going to have limit as x approaches 0, sine x all over 4 all over x times limit as x approaches 0, sine x all over 4 all over x. All right, good. Now in this place, what are we going to do? Look at it very well. Here we have sine x all over 4. Let's factor out x in this sine x all over 4. So I factor out x. You are going to have 1 all over 4 in bracket x. Is that true? Yes. So here we have limit as x approaches 0, sine 1 all over 4 in bracket x. Because when you say 1 all over 4 times x, it's going to give you x all over 4. You get it? Good. So here we have sine 1 all over 4 in bracket x all over x times limit as x approaches 0 sine 1 over 4 in bracket x all over x. You get it, right? Good. Now, we say that anyway we have limit as x approaches 0, sine x all over x is equal to 1. And the limit as x approaches 0, sine px all over x is equal to p. So here we have limit as x approaches 0, sine 1 all over 4x all over x. What is it going to give us? It's going to give us 1 all over 4. So the first limit gives us 1 all over 4, and then the second limit gives us 1 all over 4. So 1 all over 4 times 1 all over 4, which is equal to 1 all over 16. So therefore, we see that limit as x approaches 0, sine squared x all over 4 all over x squared is equal to 1 all over 16. All right, yes, thank you very much for watching. Please, if you are yet to subscribe to our YouTube channel, please just click the subscribe button. Subscription is free. Like and share our videos. Stay blessed.